Hi everybody, today I'm gonna show you how to balance your lithium iron phosphate batteries. Usually the top balancing part of this video, we're supposed to tie all the pluses together and all the minuses together. But if we do that with our laboratory power source, it's gonna take about a week or maybe even 2 weeks. So to get a little head start and move it a little faster, we're gonna tie it in series as the normal battery bank is gonna be, and then charge it and monitor it all the time to make sure none of the cells go too much in voltage so that they have a problem. And we're gonna go to 3.4 volts per cell, and later we're gonna go to 3.5, but from 3.4 to 3.5 we're gonna go with parallel. So for now I'm gonna put the batteries in series and we're gonna charge them up with the laboratory power supply and move it a little faster. So now we have plus, minus, plus, minus, plus, minus, plus, and minus. Anyway, we're gonna check it again. So we have these cool copper bus bars that are nickel plated for better connection. So this is going to be our main negative side, this is going to be our main positive side. Let's check the voltage. I've checked the voltage of each cell and they're all in the same area, so they're okay. So we've got 26.29. We need to get to 27.2. That means that each cell is going to get to 3.4. But let's check again with the meter to be sure that we are at the right polarity. So this is a positive, this is negative. Yep, it's okay. So now it's 26.3. So this is going to be our main positive. This is going to be our main negative. I need to check to be sure. Positive, negative. Well, nothing went boom, so we're okay. We're charging at 10 amps at 27.1, that means 270 something watts. So we're charging pretty fast, because otherwise we would be charging at 20 something watts only. So this is going to be much faster, but you need to always monitor each cell to be sure that everything is okay. So now we're going to check the voltage on each cell to make sure everything is in order. Three point three. 3.3. Well, this one is a little higher than the others. It's actually at 3.307, but the voltage is rising because we are charging. See, this one is at 3.305. This is 3.306. 3.305, 3.304, 3.306, 7, and this one at 3.304. So they're kind of the same. Now we need to let them charge until every cell reaches 3.4, and then we're going to put it all in parallel and charge it to 3.5. I guess see you in a few hours. Now that we finished serial charging, now we need to take all the batteries apart and put them in parallel and do the balancing charging at 3.5. We're gonna measure the voltage first, then disassemble it and do everything, because you're gonna see that we did have a few cells that ran away and went to higher voltage. Not in the danger zone, but still higher than the other ones. So this is a 3.353, 3.351, 3.359, 3.41, 3.43, 3.447, 3.348, and 3.45. So this kind of ran away, but after we put them all together in parallel, this won't be a problem. They're going to balance out, and we're going to charge all of them to 3.5, so all of them will be charged. We won't go to 3.65, that's the usual for the lithium iron phosphate batteries, but for these cells, I know that if they go over 3.5, there's a danger of them bloating, so we don't want to do that because there's permanent damage to them. So now let's take it apart in high speed, and then we'll put it all in parallel. Now that we got them all lined up, I don't have enough bus bars to put them in parallel, so we're gonna use some thick wires. These are 6mm wires. We just need to make sure the polarity is okay. Now we're gonna check to see if it exchanges power, if we can. So we have 2.8 amps moving around and it's going down. So it's already balancing naturally now, from the higher cells to the lowest. Here we have 10 amps, oh my god, that's a lot. 9 amps, and it's going down as they naturally balance. 6 amps. Now we can put the charger on them to help them balance out more easily and to charge them at the same level. The initial serial charging took about 3 days on and off because while I was sleeping I wasn't leaving it to charge because of the runaway situation. So now we're gonna do it at the right voltage so no problems are gonna rise. The right voltage is gonna be 3.5 this time. But in the normal operating situation we're not gonna go over 3.4 per cell. So we set the laboratory power supply to 3.5. There we go. Now this stage is also very important. Don't put the terminals here and here. At the opposite ends you need to put them. So this is the plus lead, goes here. And this is going to be our minus, that goes here on the other side. Well, we're charging with 2.3 amps at 3.5 volts, so there's not many watts here. But this is the balancing part. So for this part you need to be patient because this is the most crucial part. After you've done the initial top balancing, usually you don't need to top balance them again ever. So the BMS takes care of that. But we don't want to equalize the batteries with the BMS because the BMS only equalizes at 1 amp, so it's not that much. It's faster this way. Now we're gonna leave it alone to charge to 3.5 and then assemble it in series, so we have a 24 volt battery, that's 7 kilowatts power. So after a few days of charging in series and then charging in parallel, we reached 3.4 volts, now it's showing 3.39 but it's actually 3.4. As you can see, it's not charging anymore. Everything is balanced now, so we can take it apart and put it in series as it's going to remain as a battery bank. After some consideration, I figured out that we don't want to reach 3.5 because as you can see this cell is a little bloated, so it has more space than the other ones. But it is okay. I think after we start using the current from it, it's gonna shrink back. Now we're gonna take the battery apart, we're gonna put it in series, we're gonna put the BMS on it and configure the battery. See you in the next video. Bye.